So another way to do stoichiometry, and this is especially useful when you need to find a lot of information, like how many grams of excess and how many grams of product and percent yields and things like that. When you have to do something that would take multiple stoichiometry steps, this can sometimes actually shorten your work. So BCA table, BCA stands for before, change, and after. Okay, and you always put moles in the BCA table. All right, you never put grams in there. If you have something that's told you in grams, like say you start with 5 grams of this product and 7 grams of that product, just write it above your equation. Okay, that way you know what it applies to, but you'd have to convert those to moles before you put it in the table. Okay, so this table will essentially look like moles of AB, moles of CD. Now for the products, got to think about before you do the reaction, how much product are you going to have? Hopefully you're recognizing that you shouldn't have any yet. So that's going to be 0, 0. Alright. So change, this is going to be either you lose some or gain some. Alright, in the reactants, you're going to lose so many moles of AB, you're going to lose so many moles of CD, and then you're going to gain product. Alright, and then for after, at least one of your reactants is going to be 0. Okay, and then the other one may be 0, or it may have some left over. It depends on if you had a perfect ratio of your reactants or if there was excess of one of them. And it can go either way. The first one doesn't have to be the limiting reactant. It could be the second one. Okay. And then as far as your products go, this is going to be equal to what you added to 0. And this is going to be equal to what you added to 0. Okay, so let's see this with an actual problem. We've seen the couple of samples that I have in here before, at least to the point of finding limiting reactant. Alright. Now this information is given to me in moles, so I don't need to write anything above aluminum and iodine, I just need to plug it into the table. So I've got 1.2 moles aluminum and 2.4 moles iodine. And then I'm starting with 0 moles of the aluminum iodide. Okay? Now, the change. This one you do need to figure out your limiting reactant. Few ways you can do this. Those of you who are good with ratios and figuring this stuff out in your head can probably see the ratio already, but what you can do is apply the molar ratio step. We have 1.2 moles of aluminum, okay, which has a ratio of 2 moles of aluminum, so that I can cancel aluminum out, to 3 moles of iodine. Okay, so I'd take 1.2, multiply it by 3, and then divide by 2. Okay, which would mean that I would need 1.8 moles of iodine. And then this, since you know that 1.8 is less than 2.4, you know that your limiting reactant has to be your aluminum, because it's not going to use up all of the iodine. Right? Now if you did it the other way around, because just in case the first thing you try is actually your excess, you're going to have 2.4 moles of iodine, which is going to be 3 moles of iodine to 2 moles of aluminum. Alright, so 2.4 divided by 3 is 0.8 times 2 is 1.6 moles. And then you can see from there, I don't have 1.6 moles. Okay, so either way you do it, you can tell which one's your limiting reactant. You'll either use the limiting reactant and then realize that you need less of what you have of the other product, showing you your excess. Or you'll use your excess product and recognize that you're going to need more of the other product in order to actually do it. Okay? So this one is our excess. So, since that's excess, we know we're going to use all of our aluminum. Right? We know we're going to use 1.8 moles of iodine. Right? Now the next step is finding out how many moles of product we're going to make. And again, this comes down to your molar ratios. Okay? To figure out products, you take your limiting reactant, the 1.2 moles, and set up your molar ratio. Okay, so it's 2 moles of aluminum to 2 moles of your aluminum iodide. Alright, 2 to 2 ratio, that's all going to cancel out, so you make 1.2 moles of aluminum iodide. Alright. So afterwards, we are going to have 0 moles of aluminum left. We're going to have 0.6 moles of iodine left, and we are going to make 1.2 moles of our product, aluminum iodide. From here, now that you have moles, if the question asks for you for something in grams, like how much excess is left, how many grams of product you made, you just do molar mass. Right? So you set it up if you wanted to find the aluminum, it'd be 1.2 moles times the molar mass of aluminum in grams over 1 mole of aluminum iodide. So let's do one more. This time, we're starting with grams. Okay, so I wrote my grams up above because I don't want to put those in the table. The only thing that can go in the table are moles. With those, I'm going to have to convert to moles in order to be able to put it in the table, so that's what my dimensional analysis would look like. Alright, we've seen this before. The 1.2 grams of aluminum divided by 26.982 grams in the molar mass gives you 0.044 moles of aluminum. And then the iodine, 2.4 divided by 253.810, gives you 0.0095 moles of iodine. And then we are, again, starting out with 0 moles of our product. Alright. So this time we need to figure out which one's limiting. So 0.044. Especially when you get to numbers kind of like this one, it sometimes is a little more difficult to see what the ratio is going to become. So I like to do my molar ratio. 2 moles aluminum, 3 moles iodine. So 0.044 divided by 2 would be 0.022 times 3, 0.066. Which, if you look at it, do I have enough iodine in order to actually supply the usage of all of my aluminum? If you look at it, 0.066 is more than what I have available of iodine. So what this means is that iodine is actually my limiting reactant. Okay, so I know this one's going to change by losing all of it. And then I'm going to do this one more time. 0.0095 moles of iodine over 3 moles iodine, so that they cancel out, and 2 moles aluminum, which gives you minus 0.0063 moles of aluminum being used, right? Which is also going to tell us, because we have a 2 to 2 ratio between aluminum and aluminum iodide, that we're going to gain that same amount of moles of aluminum iodide. So in the end, we end up with 0.038 moles aluminum left over. 0 moles of iodine left over, and 0.0063 moles aluminum iodide produced. Okay. And then if you needed to from here to find either how much excess reactant is left or how many moles of aluminum iodide you made, you just have to set up your conversion from moles to grams. So using the molar mass of whichever thing you're figuring out. So this video is really meant for review, or if you were absent, but please ask any questions that you have.